All right. So uh, let's see where were we. Okay. So let me see how many guys remember what we covered in the previous class. Okay. So the last class topic was NTP, right? Network Time Protocol. Okay. So anyone knows what is the packet or what kind of communication NTP uses? So let me give a hint. Is it a TCP? It's a UDP. So do anyone know what kind of transport it use, as well as what is the number which was covered in the last class? Okay, great. Okay. What is the stratum range? Okay, so it's 0 to 16, but the good ones are 1 to 15. Okay, 0 being atomic source and which we cannot use, and 16 being unsynchronized. So that's a bad example. So it's 1 to 15. Okay, so by default, if I configure my Cisco box as the NTP server, so what is the stratum value? What is the default stratum value by default gonna be for a Cisco box? Okay, great. Yes, it's 8. Okay, by default, if you configure the NTP configuration on a Cisco devices, the stratum value is gonna be 8. Okay, so let's assume this is a scenario based question. I have 3 devices connected one below other. Okay, so let's say this is device A, B, and C. So I'm going to make this as server, which is also called as master. Okay, and this is client. Okay, NTP client. For some reason, one of the network engineer configured this to be NTP client. So what is going to happen? I mean, are those all going to get synchronized, or is there kind of any issues with this design? If let's say we have NTP client in a midway, so what is gonna happen from the design point of view? Is it a good design? Is it a bad design? Do we need to do something so that to overcome this? Okay, yeah. So there will be synchronization issue, or there will be issue with the NTP packets. So basically, what happens is, no, we don't make the middle one as master. Okay, master is only one in your network. That's this one. This is going to be a master. You cannot make the master this one, but you can make this as server client role. So if you remember, server is gonna accept take the packet, adopt it, okay, and it's gonna forward it. So it's and the client role will act as the synchronization. So basically what happens is, in this kind of scenarios, you can make this as a server client, and this is being this act as the server. Okay, so there will be no so let's say I do some changes onto this. So this change will not getting reflected because this is acting as a server client. So the changes will come from only this master. Okay, that's the situation. That's the scenario here. Okay, so the today what I'm going to cover is it's a small continuation of the NTP. Okay, so we did NTP, we did check the NTP lab, but how are we gonna use this practically, right? If I'm configuring NTP, how is it gonna help me? So let's say these are my core routers. They're connected to the distribution switches, and then the distribution switches are connected to access layer switches, and access layer switches are connected to computers, okay, and end devices. So if you see, there are couple of network devices. If even if you exclude these Windows machine, we still have the Cisco boxes with us. We have routers, we have switches, right? So we configured NTP, okay, network time protocol. So let's say we configured NTP master on this. So let's say we were using a customized clock. We were making use of a GMT. So all other devices will start following the NTP server. So basically, I have to make use of NTP server, NTP server client over here, and these all act as NTP client. Okay, so these are all NTP clients. So basically, they all will follow one similar clock. So throughout this diagram, you're gonna get a similar clock and the date and certain timestamp or certain time zone. Let's say you don't want to follow UTC, instead you want to follow your own local time zone. Like might be you wanna your data center are in India, so might be you want to use IST instead of UTC. It's more helpful while troubleshooting, right? So we configured all NTP, all those things, but where is it getting utilized and how is it getting utilized? So let's say if I make use of a SYSLOG server, okay, I'm just gonna give it some IP 192.168.1.150, okay, and let's consider all these are also in the same network 192.168.1.0/24, or let's say x.24, and they all are running on IST. That's a plus point for me, okay. And now what I need to do is I need to enable some logging, okay. Logging is nothing but it's your system log messages, okay. So let's say if the CPU utilization is more, or let's say if one of the interface is going down, or let's say there were some critical warning messages, right? So whom do you want to send it to? Do you want the network engineer come and manually check these devices? Is it only the work a network engineer has in a production area? So this is just a simple example with might be 10 devices. But let's say if your enterprise has 100 devices, would you log into each one of them and then you manually run the show logging command to see if there is an issue or if there is everything running fine? That's not very feasible, right? So what I do is I configure a logging server, or I can say I configure a server, I assign some IP address. I have to do one time configuration. I mean to say on all these devices there will be one time configuration, that is nothing but pointing to the server. Okay, I'll manually go to these boxes and I say my logging server is hosted on 192.168.1.150, and this command I have to place across on all of them. Now what happens is in my day-to-day network activities or in my day-to-day troubleshooting, I don't have to go and manually check on any of the boxes. If something happens, okay, if something happens, if there is a warning message, if there is an interface going down, they are automatically going to send to the syslog server. So my work would be very simplified. Now I just need to keep a watch on only syslog server. Okay, if something goes down, I'm gonna get notified here, so I don't have to manually check them individually, or uh, try to analyze on what device, or whatever it is. So my syslog server is going to get all the messages, and then the syslog message is going to show me what is the issue, from which device is this coming up, and at what timestamp was that alarm got triggered up. So the timestamp is that nothing but the NTP that we did in the previous class. So basically this syslog is a small continuation of the NTP part. Okay. So in today's class, what I'll do is I'll try to integrate both of them. That is your NTP and the syslog server, like how it is kept in a production. Something like we see in the production environment. Okay. So if you see my diagram, I have my NTP server over here. I have the two clients. One I took as server client for testing purpose. Okay, the other one I took it as client. And to demonstrate syslog server, I am making use of this box. This will act as a syslog server. Okay, it's one of the Docker from GNS3. It's called as toolbox, or toolbox kind of thing. Let me show you how does it look like. So if you search for GNS3 marketplace appliance, okay, it's called as networkers toolkit. So what does this ready-made container, or this ready-made Docker does is, or I can say it as template as well. So basically it is capable of handling these features. It's just a 1 MB to 2 MB file size, and it can have these many features embedded inside it. It can act as a www server, it can act as a FTP, it can act as a TFTP, it can also act as a syslog. So this feature I'm trying to do it today. Okay, it can also act as DHCP, and it can also act as a SNMP server. So whoever developed this appliance, so he did a great job. We can use these many features, and we can test the packet structures. What is the source, what is the destination, how the protocols are being operating. Okay, so that's a good thing. So this is that same appliance that I have here. It's a toolkit, networkers toolkit. Okay, so let me show you how does it look like. So what I did basically was, I went first to edit config, and I gave it a static IP. Okay, so this is how you give a static IP. You just need to remove the exclamation mark. Oh, sorry, not exclamation mark, it's a hash symbol. So you just remove this hash symbol, and okay, let me show you something which is non-configured, or not configured yet. Okay, so let me pull one of them. So let me pull toolbox from here, and if I right click on this, so this is a default configuration. Okay, so let me just take this, put in my notepad, write it as default. Okay, I'm gonna take this out, I don't need this. And now let me come here. Okay, So this is post configuration or the current one. So if you see, I only did some changes across in front of these lines. So I just removed those comments part. Okay, these are nothing but it makes them non-functional if you keep this. So by removing them, I make them functional. So it's gonna act in a static mode now. Okay, static interface configuration. If you just untick them and untick this part, it's then gonna be act as a DHCP. But we don't want DHCP. Let's configure a static IP. So I just gave one static IP 1.151 and the normal gateway and subnet mask. Okay, so you will get this included in the network topology itself. But I'm just trying to say, in case if you wanna deploy might be another server or something in future, so you need to know how did I do this. Okay, fine. So I have a syslog server, I have my NTP core, I have NTP client, and there's one more NTP client. So let's see if we are good with the NTP first. Okay, because that's the first thing, and then we will proceed to the syslog thing. Okay, so let me see what is the show clock value. Okay, it says this is the show clock value. And what about the clients? Are they following it? Show clock. Okay, it says Feb 20. So let's see, is that right? Yeah, it's Feb 20. Okay, let me see the NTP status. Okay, it looks like it's following. Let me see the synchronization method. Okay, if you see, they are still unsynchronized, but don't worry. They are still working. Okay, they are still working. They are following show clock. Yes, it's following too. Okay, it's working too. So let me try to shut and or let me try to bounce the port once. Okay. I'm just trying to bounce all the connected interface. Though they are already synchronized. Okay, so there is nothing wrong with that, but I'm just trying to do a repolling. So this is master and broadcast. So this is a server client, and the last one would be only client. So this is client. Okay. So this is fine. Last update was 7 seconds. Okay, so it's going to take some time. Okay, so NTP are very slower. So we have all the configuration in place, so there's nothing. So we can see that it's pointing to server 192.168.1.1. So okay, so the IP is wrong, right? It's 98. Okay, so looks like there is a conflict in IP address. Okay, let me quickly fix them. So 137 and 1.98. So I must point my NTP server towards 98. So if I come over here on the first device, I say NTP server is 192.168.1.98. It's running on version 3. And I'm gonna remove the second IP, whatever I see. Okay, I'm not sure how I got this. And same thing over here. Okay, so it's 98. Okay, so basically I'm pointing these towards my server. Do show NTP association. Okay, it says 98. Okay, now you can see the clocks are synchronized. Okay, so they might there was some typo error with respective to IP address. So let's see from the second client point of view. Show NTP status. Okay, so you can see clock is synchronized and they're referencing to 1.98. 1.98 is your server. And when was this updated? It was just 22 seconds ago. The clock were synchronized. Okay, so now we are all following a single timestamp. All the three devices are following the similar timestamp. Okay, so now at this part NTP is done. NTP is configured. Now let's talk about the syslog server. Let's try to push all the logs to an external server. Okay, so let's see what is the logging right now. So if you see, there are so many logs. Okay, there are so many logs which will get wiped out if there's a reboot of this device. The all the logs are gonna get removed, right? So what I'm going to do is, on a real time basis, I'm gonna push this logs to an external server, and external server will keep these records for like last 1 month or last 2 month or might be for last 6 months. Okay, so the configuration for a syslog server is quite simple. You just need to point them. Okay, so let's say from my client 2, okay, that's over here. Okay, I'm just pointing it to my syslog server. So let me show you what I'm going to do it. So I'm gonna say logging server. Okay, logging host. Okay, not server, logging host, and the IP address of the server. So here in this case it's 151. So I'm gonna paste it. Fine. So this doesn't end here. You need to define what kind of syslog messages are you gonna send. Okay. So let's say you're gonna send trap messages. Okay. If I do a question mark, so let me show you what else you have. So you get lot of options that you can send to an external server, but you don't want to bombard your server with all unwanted messages. Okay. You can send buffer messages. You can have the all other things, history, the monitor messages. You can send lot of things. Okay. But we will send only the traps that we enable. So I'm gonna write trap now, and then again do a question mark. So what level of trap you wanna send? Do you wanna send all the alerts, critical messages, or debugging, emergencies, error, informational, or notification, or warning? So what are you trying to send now to the external device? So be more specific. Otherwise, you will get daily 10,000s of syslog messages, and then picking out the real one or picking out the genuine alert would be very painful in this scenario. So send only those error which makes a critical impact on your production. Don't send every other syslog messages. Okay. So I say logging trap, and I'm gonna enable one of them. So just make sure if you enable 7, so by default all the other numbers like 0, 1, 2, 3, 4, 5, 6, they are gonna get enabled. Okay. Similar way, if you have 4, that means the 0, 1, 2, 3, 4 are gonna get enabled. So what you do is, so just for our lab purpose, I'm gonna enable some of warnings. Okay. So that I can show you how does they move toward to the syslog server. There are two ways to do this. I can say logging trap warnings, or I can write that code over here. Okay. So the code is 4. So I can also write 4 and I can press enter. Fine. Only two commands will start pushing all my syslog messages to an syslog server. So let's open the syslog server now. So this is a Linux based Docker given by GNS. Okay. And how do I read the syslog message? So the path, there's a syslog package installed in this container, and this path you need to follow. Okay. cat, you just do cat and go to where log syslog. Okay. So here is where you're gonna get all your syslog message getting accumulated. Okay. So if I do enter, so we can see there are syslog comings from our network devices, right? So these are all our syslog messages that are from the network devices. So how do I confirm? So see, this is the device that's sending this log messages, and who is 1.100? It's my this client, right? So you can see here 1.100. So basically, as soon as I configured logging host and I just triggered that logging trap and some levels, it started sending all its uh, internal log message to the server. Now the server can keep a record for last 6 months, or it can also keep the previous 1 month of record. But whereas the logs which is present on the box, okay, they will get overwritten. Let's say you have thousand of logs for the day, might be next day those thousands will get replaced by the fresh lines of code. Okay. Now let's say someone send you a troubleshooting ticket, and you have to troubleshoot a ticket which was flagged like 2-3 weeks back, and you don't have the logs with you because the device is not gonna keep so many days of logs, right? So you need to make sure the logs are back up somewhere externally. So that's how the syslog server over here in my lab I just showed you. Okay. But in reality, in a production, we get lot of packages for syslog. You get paid version, you get free version. There are couple of packages. Okay. So some of them are, so you can see these are one of the vendors. So if you can just see syslog vendors. Okay. So basically our enterprise buy one of the syslog package from them. So these are the best syslog server. You might have already worked on at least one of them by now, right? You might know what is Splunk. At least that's very famous, right? You have the PSLR PTG syslog, which is again very famous one. So what enterprise does is they take the package, they buy the package and they deploy it on their VMware or EXI or on their servers, and then all the devices are pointed to that server wherever you're gonna put this syslog package. Okay, so this package could be in various uh, extension. Let's say if the vendor is supporting the Windows package, then you will get these syslog in a .exe format. Let's say if it is a VM or a EXI, then yes, you can get the OVA file. So basically you have to load it up, and all your networking devices you need to point on to this syslog server, and they start uh, accumulating all the values or all the syslog messages. Okay, so now what is what in this? So if you see here, it's still showing you some date, and over here you are still seeing something else. The reason is you have not changed your timer on the syslog box. Okay, you just deployed it and you started accumulating it. So that's why it's having the current date. So what is the current date? How do I see? So if I do uptime, okay, let's see clock. Okay, so if you see if you make use of the date command, so it's gonna give you the current date. Okay, so that's given by your syslog message. So you need to discard this timestamp. This is not gonna help you. So what is gonna help you is this message. Okay, so this says the syslog was sent by this box. Okay, so if you open up your uh, lab, so this is that box who is sending continuous syslog messages to this. Okay, and we are over on this box and we are trying to analyze those logs. Okay, so it says this is the this is the box who is sending this. This is the sequence number. 221 is sequence number. This is the timestamp of that box, the box who is trying to send you. Okay, so if you see Feb 20, that's because of this box. So there is where the NTP is playing its role. Okay, you can try to keep this something which helps you while troubleshooting. If you want to keep it with respective to IST, that's fine. That's fine. All of them are going to be in IST, so that it becomes more easier while troubleshooting. Okay, otherwise you have to end up converting to UTC, might be UTC to some other time zone, and it's a long process. Okay, so this is timestamp. This is a short code to tell that the issue is this. Okay, I'll tell you what exactly is this called, and then you have a long description. So if you see the other part, it's a long description. So you have a short description and long description. Okay, so this is how a syslog message looks like. Okay, so let's go to the PDF and I'll show you some important points. It's a easy topic. It's only about how it works and what is the package structure. Okay, so let me quickly show. Let me just quickly walk through the points. Okay, so syslog server is nothing but system logs or system logging. Okay, it's a standard protocol used to send the system log. Okay, so all your router, switches, firewalls, access point, any devices, they will produce their own logs, right? And you are sending this logs to an external server so that your logs are safe at some point. Okay, even if this device goes down, or if this device is not able to keep more than a day of logs, you don't have to worry, because you are sending all the logs to some server, and the server is gonna keep those records for like past 1 month or for a past 6 month or something. It's gonna keep a record, might be for a longer time with it. Okay, who are gonna send, it's your network devices like routers, switches are gonna use syslog server and send the syslog message. Okay, so basically if you're trying to run some debug commands, so how do you take the output and you start analyzing? You just put a cursor, say, let's say this is my one of the device, a network device, okay, and I run the debugs. So what happens is, after stopping the debugs, I'm gonna just make use of this kind of method to copy and then paste it somewhere, right? So something like this, right? But with the help of syslog box, you just are trying to send it to syslog box, and that's more convenient way, because you might be having the debug on 10 devices, and it's on a real time getting captured on the syslog box. Okay, so it says the debug output to a local logging process inside the device. Okay, syslog is used in variety of devices to give system information to the system admin. So if a interface goes down, if a CPU is more, if a CDP neighbor is having a duplex mismatch, so basically you don't have to log into individual boxes. Okay, it's going to go to the syslog box or the syslog server and just keep an eye on your syslog box. That's all. Cisco devices use Cisco protocol to manage system log and system alerts. So by default, what are you gonna send to the syslog box? It would be fault notification, network forensic, and a security auditing. Okay, like network fluctuations, interface fluctuation, CPU overheads, right? Lot of system messages. Syslog message can be output to the console, local buffer, and remote syslog server. That's why I said we are not gonna enable everything. We are just gonna enable those messages that would impact the network, right? If an interface is going down, that means that's a critical message for me. I need to uh, send only this message to syslog box, not that I send everything to the syslog box, and might be my important or the critical message get it just get to the second page immediately, right? So I don't want to do that. I just want to filter. So I have the provision of making use of traps, and I can go with the levels. Okay, I in the lab I just showed you level 4. What else is going to do? So the syslogs, it can include content flow, configuration changes, or a software install. So let's say if an interface goes down, or if you did a new interface configuration, or if you're trying to install something, or your device uh, was upgraded with a new image. So basically everything which is recorded on a logging show logging command will all be pushed to the syslog box. So let's say you just rebooted your device and it was stuck at some moment. So while going through the syslog messages, you can understand, okay, so the issue was exactly at this and this point. Might be after reload the box doesn't comes up, right? So it becomes more easier for you to troubleshoot, and you know where exactly this issue arised. So that's about this line. Logging helps to detect unusual traffic, network traffic, device failure, and issues. Yeah, so basically we are forwarding it to syslog server, and it's getting recorded. It's a UDP protocol, and the protocol number is 514. Okay, important from the technical round of view. So there are three things that happens in syslog, or you need to do, three things which make a syslog server fully functional. Okay, so basically what syslog does is, it's going to gather logging information for monitoring and troubleshooting. The type of logging information can be captured. It's on a user requirement. If a user set 4, then you will capture all the levels of 4 packets. Okay, and specifying the destination of captured syslog messages. So basically, who is sending the packets, right? So that's important. Otherwise, how would I know that this is from this device and not from something else? Let's say you also had some other device, right? So the destination should also be there. That makes more sense to troubleshoot. So you come to know, okay, this is from so and so box. Okay, so if you see this graph, your router, your switches, they're gonna send the system messages to the syslog server. Okay, and they are gonna get stored in this box. These are the different levels. Okay, so you just set something and you can just recreate the issues. Now this is the format that I was talking about. Okay, you have a sequence number, you have a timestamp, uh, you have a short uh, issue, and then you have a long description of that issue. Okay, sequence number, timestamp, facility is nothing but to the message it refers to. Okay, the facility to which the message refers to, if it's a CDP issue, or if it's a interface issue, or if it is related to CPU issue. Okay, severity is nothing but the value that you're gonna set. In my case, I set it 4, so that becomes the severity representation. Mnemonic, or I think it's pronounced as mnemonic, so it's a short form to describe the issue. Okay, so it says text string that uniquely describe the message. So I can also say the shortest or a shortest way to define the issue. And then you have the description, which is a complete detailed information. Okay, so if I show you one from the real box, okay, which I captured from this, so I've just tried to color it out so that you know what is what. Okay, the first one being uh, the timer. Then you have so basically these are the timers. You have the sequence number, you have that short form. Okay, now it's a link issue. So this is facility. Okay, if you see this act as facility, so that's what is written. Facility is linked. What is the severity is this, right? And then mnemonic, which is nothing but it's up down. So basically this is helpful. Let's say you are on a call with Cisco TAC and you're trying to convey your messages to them that one of your device is having a link issue, right? But how do you know it's a link issue, or something else, right? That's when you need to analyze. You need to know how to analyze this syslog message. So they will be straightforward. If it is a link issue, it will show as link issue. If it is a CPU issue, they are gonna show you the CPU word. So then it becomes more easier for you to convey the same issue to a Cisco TAC, or might be some other vendors, or might be if you're discussing it in your team management call or kind of something, then it becomes more easier if you know the format of syslog message. Okay, how do we configure syslog box? Very simple, just one logging command and setting up the traps. That's all, right? But over here I have 3 steps. The third step is optional. If you want, you do it, otherwise you just ignore it. Okay, first step is defining the syslog server. So you go to all your devices, Cisco router, switches, ASA firewall, access point, all the network devices, and point it to a syslog server. Okay, and in my case this is the server, from the PDF point of view. Okay, 192.168.1.3. But if you talk from the network diagram point of view, it was 151. So let me also write it if it helps. Okay, 192.168.1.151 was my server, or the syslog server. Okay, and all the network devices were sending the syslog message to this device. That's the first command that you have to enable on all of them. The second command once again you need to go back to the network device and enable with respective to the level. Okay, and the third one here is with respective to the source of the packet. Okay, so basically what happens is this is optional, it's not a mandatory command, you just need to enable the source. Okay, so basically what happens is by default the exit interface is gonna get considered. Okay, so let's say if I have a router and let's say this is connected to syslog box. Okay, might be this act as source. Okay, or might be if the packet is going out of this, then by default the outgoing exit interface is gonna get considered as source. Okay, so if you open up the Wireshark or if you see the packet capture, you will see the source acting from a different point of view. So if you want to avoid those confusions, you can bring up your loopback address, might be you can configure a loopback address. Okay, or this existing or this outgoing interface which directly connects to the server, let's say if this is 0/0, now you can set as source for all the syslog message. So no matter if your traffic is still going in this direction, since you have this command, so basically the source will be this, it's gonna get considered this interface. It's a optional command, it's not required for syslog to bring up. It's just an optional command so that you know from where these packets are originating. And if let's say from one router you're getting 10 packets, might be 10 packets will have a different source address, right? So to reduce that, you can keep one source address so that only that so that all the 10 packets will have only source of the router 1 or whatever device is sending. Okay, so on a network devices, this is the command that we use to see the logs. Okay, show logging command. And on my lab, I made use of a different command with which is a write command for a syslog box. Okay, and that was this. If I do a cat on a syslog messages, so I can see the various syslog that's sent by this person. Okay, 1.100. So you can see there are a lot of things. So let me do one more thing. So let me just bounce a port. Okay, let me make it shut and no shut. So you're gonna get some message. So let's see if I get them on my syslog box, right? So you can see syslog message are on a real time. It was just a fraction of second and you have them. Okay, so let me show you the packet structure. Okay, let me show you the Wireshark, how these syslog message look like. So let me filter the packets for syslog messages. Okay, and if I take one of the latest one, okay, the link up and down, so you see the syslog message which is over on UDP 514. Okay, you see this is UDP 514. This is your syslog message. Let's see the content of syslog message. So it says it's on level 3. Okay, but we had enabled 4. So that was my point. If you create 4, all the lower ones are by default getting started up, like 0, 1, 2, 3, 4. If you open up 7, then all your 0, 1, 2, 3, 4, 5, 6, 7 all are getting enabled by default. So that's why 4 will include even 3 as well. Okay, and this is the syslog string that we discussed, the timestamp, the sequence number, the facility, the long description, the short description. Okay, so this is about syslog and how the syslog message would look like. So any doubt here? Because I am planning to take one more topic, simple topic, not very not a major topic, but yeah, so I would like to take a little Q&A as of now, because since it's a second topic, I don't want to keep at that end. So are we good with syslog?
I have a question with regards to NTP sync.
Okay.
What is the frequency of
Sorry,
what is the frequency of the NTP sync?
you mean to say the polling time?
Yeah.
So polling time is 64, but I think it's on minutes. I guess I'm not sure on what value it is, whether it's a second or if it's a minute. So if I show you here, so it's set to 16.
Okay. Is it 16 seconds?
I guess so, but it cannot be 16 second. It might not be 16 seconds. So I'll tell you this, whether it's in a second or whether it's in a minutes.
Okay. Okay. So can we configure multiple NTP server for redundancy
Yes, we
or
can
just it?
configure multiple NTP servers.
Okay.
So we can set multiple servers, and the key determines which one to be considered. The lower key gets the first preference. So if you see here the PDF, in my last lab I talked about setting up some keys. Okay, some see
Oh,
over here.
NTP trusted key.
Yeah,
Yeah.
so
Okay.
that's gonna determine which server will be acting as a master whom to follow up.
Okay. Also, can we sync up to some server on the cloud as well? Just to, I mean, sorry, onto the internet NTP servers, or how
Yeah,
do I sync my
y-
NTP servers cloud?
yeah. So we have NTP online servers. So in case if you don't want to change your hardware clock, or you don't want to keep your uh, internal clock as a source, you can point towards the online NTP sources. So doing
Okay.
this will automatically get synchronized with the server. But issue is, in case you lose your internet, then that's gonna create the issue.
Uh,
So yeah, so what most of the guys does is they keep a server, and they set the hardware clock, and then they reference to the hardware clock instead of falling to a internet server.
okay. Got it. Thanks.
Okay, no problem. Okay, so NTP syslog. The next topic is interesting. You guys might be aware of this. Okay, it's DHCP. So any idea where we see this DHCP, and what is the use of DHCP? I mean, how does DHCP help you in enterprise when you have uh, 5,000 of users getting their laptop to the office? How is the DHCP gonna help them, or might be help you as a network engineer? So let's say these are different laptop users. Okay, so I cannot draw like 5,000, but I can just draw few of them, and I can say that they are like 5,000 of users, laptop users. Okay, and then they have their own ways to connect to our network infrastructure. Might be they have access point, so they can make use of Wi-Fi, and the access point internally connected to a switch, or they can make use of RJ45, which is directly coming from the switch. Okay, so let's say this is somehow connected to all switches. Okay, and these access layer switches are now connected to distribution switches. You have a distribution switch here. Okay, and finally they are now connected to the core, and might be you have two ISP, might be this is acting as ISP 1 and over here you have ISP 2. Okay, so where is DHCP used, or where is this getting or where are we gonna see this DHCP coming? Is it on the ISP side? Is it on the distribution side, or is it on the access layer?
Distribution.
Okay, so basically, the DHCP is more towards the user side. Okay, that's over here. Okay, the reason is all the network devices will be configured with a static IP. Okay, I'm gonna give static IP here, I'm gonna give static IP here, I'm gonna keep a static IP here. Okay, I'm gonna keep the static IPs everywhere, but the users are not something which we can configure on static IPs, because that's a wasting of an IP, right? Let's say this user, if I give him an IP of 1.1.1, okay, thinking he's my he's my colleague or he's my teammate, but let's say he goes for work from home. So what happens is my static IP which I assign him, which I am binding it saying that this user's laptop has this IP address, is gonna get completely reserved for this user, even though he doesn't come to the enterprise or he doesn't come to my uh, office, but that IP is gonna get reserved to him, right? So gradually what happens, as we start seeing a lot of users coming in, the IP address start getting falling shortage. Okay, they are gonna get exhaust. So what we try to do is we keep this computers on DHCP mode. That is, if you come to the office, you will get an IP. If you are logging out and going back to the home after like 4-5 hours or 8 hours, the IPs are gonna get to a different guy who is in that office, who is might be coming in the second shift, or might be he's coming next day, right? So IPs are not gonna get reserved. So one benefit is that DHCP. But where are we going to configure DHCP? So it can be configured on distribution layer. Okay, it can be configured here. I don't say that we cannot configure on the core. Okay, it depends on your network size. If it is uh, a small scale, then lot of small scale enterprise, they have the DHCP configured on the core. And if it's a large scale with 5,000 users or 10,000 users, you basically don't do configuration on core, because core will be kept only for BGP and the WAN connection only. The DHCP will be configured on these boxes, the distribution boxes. Okay, so DHCP, and you have a backup over here. So how is now that's gonna help me? I mean, if I configure DHCP here, what happening? So let's say from the network point of view or network administrator point of view, uh, let's say if someone let's say if we have a 10 let's say we have like 100 of users who visit office on daily purpose. So I just cannot go to their laptop and then just cannot configure an IP address to them, right? It's not something very feasible in the network. I want something to be automated. So as soon as they come with their laptop and they connect to the network, there will be some packets originating from the backend. Okay, so as soon as, let's say, this user, he boots his computer and his Windows just comes up. As soon as the computer comes up, what is it going to do is it's gonna send some packets. Okay, the packet is called as DHCP discover packet. Who is gonna send this? Who is gonna initiate? It's the client. So let me make it as client, and let me say this is a server or a DHCP server. So discover packet will be forwarded to the server. And now what DHCP server does is, as soon as it see that there is someone who is requesting for an DHCP IP, it's gonna send, or it's gonna offer the IP. Okay, so it's gonna send another packet back to this, and that's called as DHCP offer. Well, so what is offer gonna contain? Offer is gonna contain the IP address, the subnet mask, the gateway, the lease time, all the information this packet is gonna include, and it's going to come here. So do you think the client will immediately take it up? No, client will not still take it up, because who knows, the other user might have also initiated the discover packet, and might be DHCP server has sent the same offer to both of them, right? Now if they immediately take it up, then you gonna get the duplicate IPs in your network, right? So you don't want this to happen. So what happens is, after discover packet, okay, which client initiated, the DHCP server is gonna offer back some IP address, okay, to the client, but client is not going to take it immediately. It's not going to adopt it immediately. Instead, it will request, it will send a request that yes, I'm okay with so and so offer, keep this for me. Okay, that means in case if something comes up, okay, additionally if something comes up, the IP which was offered is not gonna be resent to a different client. Okay, so the server will send something else, some different IP it's gonna send. So request is very important. The client is gonna request that reserve this for me, I want it, and it's gonna wait for the DHCP server to acknowledgement. Now DHCP server can say, sorry, I have given this to someone else meanwhile, right? Or DHCP server can say, fine, I am acknowledging you, this is reserved for you. So the packet would be acknowledged. Okay, so DHCP server is gonna send one more packet with acknowledgement, and now this user is gonna get an IP automatically. Whatever a network engineer configure a pool over here, is gonna get one of the IP from this. So this is what happens in case of home internet modems, or when you walk inside your office. Basically you will be having a DHCP configuration. As soon as you walk inside your office, you will get an IP immediately within some fraction of second, right? But in the back end, these are the process that's happening actually. As soon as you connect your network, the client is gonna initiate some packet which is called as discover. It will go towards the DHCP server. DHCP server will recognize this packet, and it's gonna offer it. Okay, it's gonna offer them. The client will not immediately adopt it. Instead, it will request to reserve that. That's the third step. And the server is gonna send back an acknowledge packet saying, yes, that's reserved to you. You're good to use it for so many hours, or let's say for so many lease time. Or so basically what DHCP server does is, it's giving that IP on a lease concept. Okay, it's not a permanent IP that once the DHCP has given to a client, it's not going to be permanent. It's a lease time. That means until or unless you are on the same network, that's going to be your IP. But if you just log out and go back to your home, and might be the default lease hour is for 8 hours, okay, and if you don't come back in this 8 hours, that the IP is now free. The server can send it to someone else. Now the next day the IP could have been to someone else. So that's a lease concept, okay, where it's given for, or it's gonna reserve for 8 hours. Fine. So in short form, I can also write it as DORA process. Okay, so DHCP, if someone asks you to explain the DORA process, It's not that cartoon, that character. It's about the DHCP process. Okay, and I guess you guys will be knowing about the short form because it's a CCNA topic at the end. Okay, but yes, we have some more topic in DHCP which I'll take in the next class. Okay, so this was just a basic which you guys would have known if you're from if you're already done CCNA and if you're in a networking industry. Okay, so DHCP, two major importance or two major advantage. The first advantage is you're not going to set a static IP, neither you need to go towards towards the client and do something. Okay, it's gonna be automatic. It's gonna be automatic. So if a client comes towards you, and then you are gonna offer them. The second thing, it's faster way to configure 5,000 of clients, right? Otherwise you would have taken like a week time to put those static IPs on 5,000 devices. In the case of DHCP, it's all negotiation. The packet comes from client. I see this is a valid client and this is my own device. I'm gonna offer the packets, or I'm gonna offer them IP address, and that's how the negotiation happens. Okay, that's something which we need to check. So you now know. So you might be knowing the basic concept by now that what does DHCP does. Okay, but the main thing here is the packet flow. Okay, the packet flow that's involved in the DORA process: discover, offer, request, acknowledgement. So I can say uh, there are 4 steps. Okay, okay, 4 steps. So step number 1, who is initiating it? The client is initiating it. The user who comes with his laptop, as soon as he connect to the network, either on a wireless or either on a wired connection, he's acting as a client. Okay, so he's gonna send some automated discover packet. Okay, so let me say he's gonna initiate some discover packet which would be in this direction from client towards the server. Okay, so we are talking about DHCP server. So I guess you are aware, so I'm not gonna write the same thing. How would be the packet look like? So how would be the packet structure look like from L2 as well as from L3 point of view? Okay, so let me say, or let me first write L3, that would be making more sense. Okay, so let me say source and destination field. Okay, so if you remember, I said they don't have IP address. I mean, the user doesn't have IP address. So where is the packet going then? What kind of packet is it going? Is it a broadcast? Is it a multicast? Is it a unicast? It cannot be unicast because they are the client doesn't know who is the server. It's a blank computer. It's a computer with a blank IP address, zero IP address. It doesn't have an IP address. Neither it knows where is it have to forward, right? So basically it is broadcasting. It is sending to every other devices in that network. Okay, so the source will be this because it doesn't have an IP address. The client laptop don't have an IP address. Whom is it sending? It doesn't know. It's broadcasting. So for a broadcast, I would like to write in this format. Okay, all broadcast. Now let's talk about L2, the frames, the packets, the frames. Okay, so this was packet, L3 packet. Okay, and now we are talking about L2 frames. So if I write source and destination, what are they going to be? So source is going to be the client MAC address, right? So what is source going to be? It's going to be DHCP of client MAC address. Might be the laptop, or it could be iPad, or it could be a smartphone, it could be a computer, right? It could be anything. So its own MAC address will act as the L2 source header. Okay. And what is the destination? As I told you, it's a broadcast. So I don't know what whom do I need to send, and I'm gonna broadcast this packet to everyone. I'm gonna flood it. Okay. So my packet is now moving in each corner of my network, and I'm not sure where it's gonna hit now. So all the other devices are gonna drop them because they don't have that DHCP server feature enabled within them. So they are gonna drop it because it doesn't know what is after all a DHCP packet gonna be. The one which is server, which knows what is a discover packet, will respond now. Now that's a second step. Okay, I write it as second step, and this is offer step. Okay, the first step was discover. Now second one is the offer. So let's say one of the broadcast packet hits the right DHCP server, and the DHCP server recognized the discover packet, and now it's sending, or it's offering the message. Okay, and now what would be the L2 and the L3 content? So let's first talk about L3, and then we'll talk about L2. Okay, so from L3 point of view, okay, so from L3 point of view, the source will be nothing but the DHCP server IP address. Okay, whichever server is acting as DHCP will add its own IP. Okay, so here is where the source get its IP. So let's say this is the first packet where the DHCP is adding some realistic IP, because in the first step there was no IP address. It was 0.0.0 because client don't have an IP. But in the step number 2, the server has an IP, right? The server is a configured and kept at some corner. So it's gonna keep its an IP. It's gonna put that as source. Okay. And in the destination, it doesn't know. The destination was a 0.0.0, right? So basically the client doesn't have an IP address. So it's gonna broadcast it. So in this case, it's gonna send a broadcast packet. Okay, so whenever you send a broadcast packet, you need to mention 255.255.255.255. If you do not have an IP, or if you don't know what is your own IP address, then you need to configure 0.0.0.0. These are two different things. Okay, 0.0.0.0 is a scenario when you do not have an IP address. 255.255.255.255 is an scenario when you're broadcasting the packet, when you do not know whom shall you send the packet. Okay, on the destination side you do not know, and you're just broadcasting to everyone. So in this case, the source is the server IP. The destination, there is no there's no there's no information of the client IP address. So it's just broadcasting. Okay, so let me take this out, and let me once again write here. So now I'm gonna talk about the L2 header for the offer packet. Okay, source and destination. So source will now be the MAC address of DHCP server. This is a second step, and the destination is going to be the client MAC address. And how does the client MAC address was known to the server? It's because the first packet, this L2 source was the client MAC address, right? So it's gonna keep the same MAC address of the client now. which it received in the discover packet. So this ends your offer packet, or it was an offer message. Okay, so in this particular step, the layer 2 act as a unicast because it has its own MAC address. The server has its own MAC address, and server also know what is the destination MAC address. But the layer 3 is still broadcast in nature because it doesn't have, the client doesn't have an valid IP address, so it's acting as a broadcast. Now let's talk about from the request packet. Okay, we completed D, we completed O, and we are now focusing on the request packet. Who is gonna reply back to reserve this? So let's say request is nothing but reserving the packet. Okay, so it's your client who is gonna initiate to server saying that keep the IP address reserved for me. So source address, so let me say L3 source destination. Okay, so still it doesn't have an IP address, so basically that's 0.0.0. Whom is it gonna send? It's broadcasting. Okay, it's just broadcasting, so it's still making use of 255 to just send it back. What about L2 source and destination? So basically the source will be its own DHCP client MAC address, and this is DHCP server MAC address. So once again, layer 2 is unicast in nature and layer 3 is broadcast in nature. Okay, this is very important. This is a very confusing terms here, which is unicast, which is broadcast, what is the packet source and destination. This is where the interviewer focus more and try to understand what is your knowledge on a CCNA or CCNP level. Okay, very confusing one, but it's very easy if you know how is it working. So this is the third step, which is called as request. Okay, where you're gonna say that reserve them, and this is how the packet would look like. Now if I talk about the last step, that's when the server is gonna acknowledge, which is the step number 4. Okay, which I'm gonna say acknowledge. Okay, the last step. So you have DORA, and who is gonna send this? This is your server who is gonna send to the client. And server L3 header, source, destination. Source is going to be the IP address of the DHCP server. Okay, but still destination is unknown. It's a broadcast in nature. Okay, what about L2 now? L2 header, what would be the source? Source is once again the DHCP server MAC address, and destination would be DHCP client MAC address. Okay, and yes, once again layer 2 act as unicast and layer 3 act as a broadcast. Okay, now very simple question, out of all these 4 steps, if someone asks you, is it DHCP running on unicast, multicast or broadcast, so you must know how is DHCP gonna work. Okay, so on a layer 3 point of view, DHCP is a broadcast. All the 4 steps are gonna be in broadcast. But from the layer 2 point of view, the first step is just broadcast, but the second step, third step, fourth step are a unicast in nature. Okay. Well, so what happens in the 5th step? So let's say there is no 5th step. I mean, let's say after the DORA process completion, after the 4th step, the 5th step is when your client gets its own IP address 192.168.1 dot something in that range which server assigned. What else other than IP address? It's gonna have subnet mask, it's gonna have the gateway. This is all offered by the server. Okay, what is the lease time that I said? a lease time of 8 hours. So by default it's 8 hours, but we can change it to 24 hours as well. Okay, so these are few things which the client is gonna get after the 4 steps. Okay, fine. So let me show you in very simple uh, way how, where do we see this. Okay, so if you open up your adapter on your Windows machine, so these are called TCP IP suite. Okay, these are called TCP suite, TCP IP suite. So if I open up my adapter, if I go to the TCP IP suite package, this package, okay, TCP IP4, if I double click, there are two options. Okay, one is obtain the IP automatically. Now that's where the DHCP comes. Okay, so this is where the DHCP that I just discussed comes. Okay, and the other one is the static. So a computer or any device which is capable of having IP address, okay, will have a TCP IP suite, and it will have two ways to configure the IP address. One is called as DHCP, the second is static. So most of the time the servers, those devices which are going permanently on a one row, or the devices which are going to be always there present in my network, we are gonna give them static IP because they are not dynamically changing all the time, right? So we are gonna keep them some uh, static IPs. And the user's point of view, the users who comes on one fine moon day, fine. So on those system, we don't give static IP, we give the dynamic option. That we give this option. So he walks inside the office with his laptop. He opens it up. He power on the system. As soon as the TCP suite just see that it's configured on DHCP, automatically obtain an IP address, it's sending discover packet. Okay, so my client is initiating that. My client is sending discover packet, and it's keep on sending because it's a broadcast in nature. Okay, and let's say I have a server somewhere, and if the server start receiving this discover packet, and the server will start responding now, and now you know what's gonna happen. The four steps, the unicast, the broadcast, the L2 header, the L3 header is something, is what we see in the case of DHCP. Okay, and if I show you the PDF, let me cover up the theoretical topic. So DHCP is dynamic host control protocol. It's a application layer protocol. Okay, it works on layer 7 because of the TCP IP, what I said. It's on a layer 7. Cisco iOS feature known as easy IP lease makes Cisco box as a fully DHCP server. Now you don't need a third party software always to get your DHCP configuration. Okay, but yes, we have some third party softwares. If you just open up Google and if you search for DHCP softwares, okay, let's write buy DHCP software, you will get couple of them. You have DHCP server for Windows, you will get them for Linux box, but our Cisco box itself can act as a fully featured DHCP server. So most of the time, if you have a spare device, a spare switch, or a spare router, instead of putting it in the garbage, you can keep that acting as a DHCP server. It's gonna give, and it's gonna work a full functional DHCP server. Okay. DHCP is a client server protocol. That means it acts as in a server client relation. Okay, so you have a server, you have a client. What is DHCP gonna release? It's gonna release IP address, subnet mask, default gateway, DNS informations, and lease time, and all other parameters. Okay, DHCP allows a network device to dynamically receive IP address. If you don't want to configure on 5000 users of device, then you have to set it DHCP. That's a dynamic in nature. DHCP will follow the DORA process, which is discover, offer, request and acknowledgement. It's an application protocol or a application layer OSI model. DHCP server dynamically configure a host, right? The users are gonna get dynamically configured. It's a client server protocol which make use of UDP protocol. And what is the port numbers? It's 67 and 68. So which one takes which port number? So let's say if this is a server and this is a client, okay, the client initiate the discover packet, right? So basically this is gonna have the port number of 68, and on the server side you have the UDP 67. So this is something which we can see in the packet Wireshark packet capture as well. So you will see whenever the packet is originating from the client, it will have the source port as 68 and the destination port as 67. And whenever the packet is replied back from server, it's gonna have source set to 67 and the destination towards client, so it will have 68. So that's what is mentioned here. Server will have 67, client will have 68. How do we configure a Cisco box to act as a fully featured DHCP? You just need to configure a pool. A pool is nothing but a range of IP networks, and you have to define a default router. Okay, and that's all. Just a two commands and your Cisco router will act as a DHCP box now. Okay, and it's an application layer protocol. What is DHCP? It's automatic in nature. You are gonna make use of this concept on computers. You're gonna configure the network information like IP address, DNS server, subnet mask, gateways, okay, and it's a set of rules and regulation. So let's say in your organization you have a lease hours of 8. Now that doesn't mean then that the lease hours cannot be changed. Might be the other organization has a lease hours of 24. So these are some policies depending upon company to company. So that's what it says. Protocol, you can set some rules and regulations. Okay, what are the advantages of DHCP? As I told you, it's dynamic in nature. It's easier way to manage the IP address. It's a centralized way. It's gonna reduce the time that you require for configuration. Okay, the DHCP server is assigning the IP address automatically. There is very less chances of configuration error, because when you have multiple computers, you might end up with giving duplicate IPs. If you have .1, .2, .3, might be you still by mistakenly you might configure this on .2. Now they will be a duplicate IP, which is a bad example of network, right? But if it is happening dynamically or automatically, they are gonna have their own process to make sure there's no duplicate happening in your network. Okay, the adding of new client to the network becomes very easy. You can reuse the IP address, right? That's the main concept here. You can reuse the IP address, so you're reducing the unwanted creation of network. So basically what happens is, when you create an IP network, okay, so this network is gonna give you 254 usable IPs. And if you don't have DHCP and you're making use of static, it's very easy for you, your static way to get exhaust all the all the IPs. Okay, so you will request for another network. The same thing happens with this. If you are having a static, if you don't have any lease concept, so basically it will take very few time to get this 250 exhausted, right? So with the help of DHCP is gonna take out or take them out of the reserve mode, and they are reusable. They can give it to a different user. centralized, easy handling of users and reusing. Okay. From the DHCP server point of view, we can have our Cisco router, a layer 3 switch, which can be acting as a DHCP server. It will have all the features of DHCP server. It will manage the IP address. We need to configure some pools. So the one which I described, I just have mentioned it in a point wise. Later, when you are revising, might be you just forget what was the server. So instead of going back to the video and rewinding back the 2 hours of video, you can just follow this PDF. So it will give you a quick revision or recall the things. Okay. DHCP client, once again, you know what is the UDP, port numbers, what is the client basically doing. So basically client is initiating the discover packets. Okay. And yes, the DHCP operations, the packet that I described is also documented. So in case you come back and revise, so you have the packets with you. Okay. And to make it more practical, I have also included the Wireshark captures. So you can see the Wireshark captures for discover packet, for offer packet, for request packet, and the acknowledge packet. Okay, these are the Wireshark captures for individual packet flows. This I'll talk in the next class, what is IP config and what is renewal. Okay, so there are 3 steps in that, and that steps is when, let's say your DHCP gave an IP address, all the 4 steps were completed, your user is happy now with an IP address. Now let's say he goes or let's say he logs off and he goes back to his home and he never comes back for next 2-3 days. Now what happens in that duration? So your DHCP is gonna do a renewal, or it's called as or expiring of your lease hours, right? So that process is just a 3 steps where the renewal happens, and so I'll tell this in the next class. Okay, what happens in that release message. Okay. Regarding to the configuration, it's very simple. I can show you, or I can also give you as an assignment, but let's see how it goes. So I have taken this part to demonstrate the DHCP configuration. Okay, this act as DHCP server, these two act as my client, and I just have a layer 2 switch which is just sitting and doing nothing. Okay, it's just for the connection basis. So I'll show you what happens when a client enters to the office. He connects to the cable, and as soon as he connects to the cable, the discover packet gets uh, originated. Okay, so as of now, let me see what is the configuration. So I have enabled some DHCP configurations only. Uh, I have just grayed out the static one. I have kept only the DHCP. Okay, let me open up the Wireshark capture here to just show you what is happening in the backend. So I don't need this NTP devices. I'll just keep the PC7, okay, which says PC7. So how do we see the interface configuration or interface IP address on a Linux box is ifconf, okay, if config. And you will see there are 2 adapters, one is a loopback adapter and one is a physical adapter, okay, ETH. So if you want to grab them, you can just give if config ETH0, it's only gonna give you one output. Okay, so as of now there is no IP address, but since it's running on DHCP, we can see some captures, or we should be able to see some captures. Okay, so if you see here, if I filter it out for DHCP, okay, So you can see there are n number of discover packets getting originated. Who is originating? It's your client that's originating it. Okay. Let's see from the packet point of view. So you can see the source is 68, and I told you 68 is a client UDP port number. What is the server going to be? It's on destination side, right? So for a discover packet, what is the L2 and L3 header? So the L2 or the L3 source will be 0.0.0, which I told you initially client is not gonna have any IP address. It's gonna keep 0.0.0, and in the destination side it's gonna broadcast it, so it's gonna have this. Okay, what about from the L2 point of view? Source is the client MAC address, destination is broadcast in nature. Okay, so step number 1, both are broadcast. L3 is broadcast, also L2 is broadcast. Fine. And you see there is a lot of discover packet. It's keep on flooding it. One fine packet will then hit the actual server. But as of now, I don't have server. So let's configure a server. So I take this router and I'll just bring the configuration so that it start acting as a server. Okay. So where is my device? My device is here. Do I have any IP address on 0/0? I don't have anything, and neither I have anything for my DHCP configuration. So it's a brand new device. Okay. So I go to the configuration mode and I just create a pool first. Okay. I say IP DHCP pool, and let's make use of CCNP. I'm gonna define the network that this pool is gonna offer. So let me say this is a pool for 254 users. So I'm gonna say network, and I'm gonna define the IPs. Okay, 192.168 1.0, and what is the subnet mask or how many hosts that you wanna give inside this pool. So I want this pool should have 254 hosts. So a class C network. Okay, and then my default network. Who is my default network? So basically default network is nothing but this interface, the interface where you are expecting your discovery packet. So let's say it's 1.100. Okay, so I'm gonna dedicate that IP 192.168 1.100 to this interface. Okay, I also have to configure that interface with that IP. That is when the pool and that interface are gonna get integrated in the backend. Okay, fine. One pool that you define, you're defining the default router. Now if you go towards the interface, give that interface this IP. Okay, and make it as no shut. So as soon as you make it no shut, you must start seeing something happening, right? So you can see what happened here. It was very instant. As soon as server came up, the server recognized the discover packet. It offered something. Okay, and let's see what it offered, because I told you in the offer message the DHCP is gonna give every detail. It's gonna give the detail of the new IP address, the subnet mask, the gateway, the lease hour, but client is not gonna take it up, right? So let me show you that over on the packet capture. So if I open offer message, if I just scroll it to very bottom, okay, if I take you over here, so it's offering some values. It's giving the values, so you can just expand them. So you can see what are the different parameters are being sent. Okay, so it's gonna give the IP address of 192.168 1.2. Okay, but my client still doesn't have. I can okay, now basically it will have it because all the 4 steps are completed, but you can see it from the point of packets. Okay, if you see the packets over here, you see the next packet is still 0.0.0. There is nothing that is been adopted so far. So you have 1.1.1 which is been offered. Who is offering it? The DHCP server is offering. What are other things that's getting offered is your subnet mask, is your request, is your router information, the DNS, the host name, the timers, the lease times, all these things gets offered. Okay. Now what client does is client request to keep those reserved for the client and not to give it to someone else. Okay. So the client is once again having no IP address, is it's gonna broadcast it, okay, 255.255 with a request to keep those information, and server is gonna send the last packet saying yes, it's fine, this is reserved to you to use this. Okay. And that's where your whole 4 steps get completed. All the 4 steps gets completed, and the 5th step is when the server has its own IP address. So if you open up the server, so you can see the IP address of 1.1. So it's after that 4 steps of completion. Okay. And packet, the headers are very important here. Okay. And I have also included them. The screenshots are included, so you can refer it anytime. And configuration point of view, it's very simple. There's just 2-3 lines, but yes, uh, you can bring some more optional commands. Okay. So if you go back to the DHCP pool where you said CCNP, you don't, let's say you don't want your server giving 1.1. Let's say you want to reserve this for some servers. Okay. So I hope I'm audible. So let's say you want to reserve this, so you can just put an exclude command. Okay. I'll just come out of this mode and I'll say DHCP exclude 192.168.1.1. Let's give some range 192.168.1.50. So let's say out of that class 24 network, I am reserving the first 50 IP address for my servers, my monitoring tool, my SYSLOG server, my some different servers. Okay, I don't want this IPs, 50 IPs to my users. So user must get something beyond 50, might be 51, 52 till 254. Okay, so this is a way we can exclude first few IPs. Similar way, let's say the user also had a requirement to go towards internet, right? So if the requirement is for going out, then you must configure the DNS server, and you can do that. So if you set DHCP pool, you can just say where is your DNS server, and you can just point it up. So let's say your DHCP server is configured on this server 50. That's why I reserved few IPs, right? Because I have some standard servers, DNS server. So I can say that this pool, the pool CCNP, if the user is using one of the IP from this pool and he wants to go to internet, so his request for DNS will be forwarded to this server. So that's also possible, and all this information will be seen in the offered packet or the second packet. Okay, if I go back to offer, so you can see here the offer will also include information about the DNS. So this is rebinding subnet. So where is DNS here? We just checked. DHCP message type DHCP IP address renewal rebinding router mask. Okay, so that's end. So the DNS is somewhere over here. So it's a part of the offer packet. Okay, so you can see here the request packet. It has a DNS parameter. So basically these are few parameters that server is gonna offer. You have the NTP servers, you have the domain name, you have the DNS server, okay, subnet mask. So this is what the entire thing. So in case of my own Windows machine, if I go to adapter, if I open up my the TCP IP suite, if I click on details, so you see there are a lot of things that I actually received from my server, right? I being a client, my laptop being a client, and my server being my home modem or something. So that modem, which is acting as server, is gonna offer me a lot of things. It's gonna offer me subnet mask, the gateways, and the DNS values. Okay, so what else are some optional commands here? So we can uh, change different things. Okay, we can also have domain names configured. Okay, we can also change the lease time. So by default the lease are going to be 8 hours. Okay, so let's see what is the DHCP status here. So if I say show DHCP server, okay, okay, let's see with show IP. Show IP DHCP, and if I make use of binding, so you can see there is one client with this MAC address which is binded to the server. Okay, so my server has only offered one particular IP so far. What is pool status? So this is a pool status. You have totally 254 usable IPs. You have only given one, and that too in a leased status. It's not a static, it's a leased. Okay, it's leased for some couple of timers. So we can see that as well. So let me say database. Okay, not database. So these are all the messages, okay, the offer, the DHCP packets. Okay, so basically this is the lease expiration date. Okay, so it says it's on June 26th. So when is that? So it's giving some time. So if I do show clock, okay, so you can see it's for might be 8 hours. Okay, so it's 25.
Hey, Sagar, you see that on the client side.
Okay, so on the client side is a Linux box. So
Normally on the host machines, like running Windows, you see it over there.
okay,
I'm not sure about the Linux box.
okay, so if I open up my own laptop, so let's see let's see from this point of view. Okay, so you can see here so it's a 8 hours most probably, right? So it's 5, yeah, close to 8 hours. So yeah, by default the lease hours are for 8 hours, but yes, you can change it to 24 hours as well. So that's a default lease hours. Okay. The same thing we also can see it on the devices, but yes, it needs little it's little tricky. Okay. So if you see the show clock, it's this timestamp, and if you see the lease expiration, so you can just calculate, it's again close to 8 hours. It's 19 here, and it's around 6:30, which is almost like 8 hours expiration. Okay. Yeah, so this is with respective to the DHCP. Let me see if there's something which to be covered. Okay, so these are the commands. These are the way you can exclude the DNS configurations, the interface IP, and on the client side, you just need to do this command. Okay. So I have not done this because on my client side I am using a GNS template or a Docker, okay, which is on a Linux format, and I just had to bring up DHCP by taking out those uh, hash symbol. Okay, but in your case you can also make use of an router acting as a DHCP client. So you just have to go to the interface and make use of this in case of practicing. But yes, most of you guys have the lab with you, so you can just make use of this part. Okay, so on the end host, these are on a Linux box. Okay, they are not a Cisco box, so you have to right click on them and make the necessary changes. So any doubt with respect to DHCP? Okay, I see a lot of chat windows. Okay, frequency of NTP sync. I'll let you know it's instant or there is any synchronization timer. IP allocations, yes, that's true for DHCP. Yes, auto assign IP to, yes, that's true. Helps in conflict resolution as well. Yeah, distribute side we do it if it's a large scale enterprise, we do it on distribute side. Okay, and if it's a very small branch or a campus, we normally don't keep distribution. It will be just a uh, uh, compressed format. The core and distribution will be one, and we just have over there. Okay. Yes, right. Yeah, Dora process. Okay. Okay, so this I'll tell you. Okay, these are all the next day of the DHCP. So basically, these are some helper address. If the primary if you have multiple uh, additional host, and in case if you do not want to configure a new subnet pool, so you can still make use of this single interface which can support multiple networks. Okay, if you can have like 2-3 networks configured on single interface. Otherwise, each pool will have each interface which will exhaust the local port of that router, right? So instead of exhausting the unwanted individual physical ports, you can still make use of IP helper command, and you can make use of the second pool, the third pool, the fourth pool on that single interface. Okay. Okay, so enable feature DHCP, as far as I remember, I think it's on it's on Nexus boxes, I believe, where you have to implicitly define enable. and yeah, also on ASA firewall. These two boxes I have seen, we need to define an additional command saying enable. But in the case of the iOS switches and routers, you don't have any enable command. You can just define pool and make sure the default router IP and the interface IP matches, so that they integrate. Because on a Cisco box, I can configure multiple pools. Okay, and as I told you, multiple interface can integrate with multiple pools. So how are that integration happening? That's because of that default router command and the interface IP. Okay, I'll tell you this. DHCP relay is a concept where server is on a different network and your clients are on a different network, and intermediately you have something which has to relay, which has to relay the packets between the client and the server. So basically this I will do a lab and I'll try to demonstrate. Okay. So you can try if config. Okay, so my GNS is closed. So you can try if config command. So that should give you pretty much lot of information. So if I do it on here on Google, let's see what all it's gonna show you. So it's kind of lot of things, but I'm not sure what exactly you are looking for. So this is what you will see when you do if config on a Linux box, which will show you everything like what is the default gateway, what is the DNS server. But apart from this, I'm not sure if there is any command where you can still see something in very detailed thing. Might be we need to see on a Linux portal or something where we get something. But yes, this command will give you a lot of information. No, 50 is not connected to internet, but 50 will help you your internal host to go towards internet. Okay, so basically what happens is uh, so the DNS topic is of course one of the upcoming topic, but let me just give you a brief. So let's say these are the users, okay, who are on 192.168.1.1, and the users are connected to the switch, and switch connected to the router, and let's say this router has the DHCP configuration. Okay, so let's say when the user opens his browser and he types www.gmail.com, how is Gmail first of all gonna be converted to that IP address? So we all know that these are only the fancy names, but behind this fancy names there is an IP address, right? So who is doing the work of that? That's your DNS server. Okay, and why do I keep the DNS information within my pool? Because after all, my request will first hit the pool, pool will forward to the DNS, and DNS will take the responsibility of converting the names to an IP address, and then it becomes easier for my router to go out. Okay, that's how it gets resolved, and this is only one time. It's a first time. The reason is the second time your browser will have something called as cache, where all this mapping will get started storing. So the second time it doesn't really have to do the lookup once again from the scratch. It knows that Google or Gmail is resolving on this and this IP address, so it will still try to load, and then it's all your internet that should be working, and then it knows how where to go, and where is the Gmail, or where is this Gmail or the domain name getting converted to. So this is a first step where it has to know what is an IP address. So that's the first step. Second step is it will see its own host file. Okay, so every Windows machine and every Linux platform will have a host file internally. So in the case of Windows, you can go to the C drive system 32 and you can find a host file where manually I can define that google.com is resolving on 111.111 and so and so. But that's not a good point, because might be Google changed their server to a different server. Now that would lead to a issue, right? So I will not make use of static configuration. Instead, the third step is the DNS. It will go to DNS. DNS will try to uh, respond or try to reach different domain registrar. Okay, there are like 7 to 8 domain registrar depending upon region. It will then see the TLD. Okay, there are a couple of steps, and then finally they are gonna get to know that gmail.com resolves to this, and now the packet is all purely the L3 routing, that's router to router. You know how the packet will finally reach to the destination. Okay, so this DNS we will talk in the next class. Okay, yeah, so 50 is gonna help you to give you the binding between domain name and the IP address. Okay, so that's not an internet. Internet is then the next step where it knows the IP address, because IP address is something which matters, not the domain name. Okay, so DNS is gonna only help me to get that IP address, and then I'll send it to the core. Core will send to my internet provider. Internet provider will take the next path and the BGP, the shortest path, attributes, all those things, and finally reach the destination. Okay, so that's a small brief on DNS. So any further doubts before I wind up?
Hey Sagar, one quick question.
Yes.
So you mentioned on Monday's class that we left one BGP topic for later. What was that topic?
That was a confederation.
Okay.
Yeah, so it's a topic which is a alternative, or it said that it's a best practice than full mesh. If you don't want to use full mesh, you have a topic called this. So that's a small topic which I'll take it sometime, might be in future, because we did a lot of BGP and I personally was little bit tired with BGP, so I thought I'll take it in future.
Okay.
Okay,
Thank you.
fine. So guys, let's meet up in the next class and have a nice day, have a nice weekend, and we'll meet up in the next class. Okay, see you all soon.
See you. Good night.
Yeah, good night, have a nice day.